Today we will answer a suggested question by one of our followers. And here's the question. If a plus bi quantity squared equals negative 8 plus 6i, then our goal is to solve for the values of a and b, wherein a and b are both real numbers. Now, you can pause this video if you want to give this problem a try. And now, let's answer this question together. Alright, so given this equation, a plus bi quantity squared equals to negative 8 plus 6i, then our goal is to solve for the values of a and b, real values for a and b, such that it satisfies this equation. Alright, so let's start. First thing we need to do is to focus on the expression a plus bi quantity squared. Now, if we expand this, we get something like a squared, or the square of the first term, plus twice the product of a and bi, so we have 2 times a bi, and then square the last term, which is bi raised to the power of 2. Now, let's simplify a little bit. bi raised to the power of 2, this will give us b squared times I squared. And now, take note, the value of I squared must be equal to negative 1. So we can replace this I squared right here with negative 1. So let's do that. Now, b squared times negative 1, this will give us negative b squared, of course. And now, let's rearrange some terms a little bit. So let's combine all the real terms and all the imaginary terms. Now, let's group them. And now, take note that the expression right here is equivalent to the expression on the left-hand side of our original equation. So let's substitute this value to our original equation like this. Now, take note, the real part must be equal to its real part on the left-hand side and the right-hand side. And the imaginary part is also equivalent to the imaginary part on the right-hand side. Therefore, we can say that a squared minus b squared must be equal to negative 8, and 2ab must be equal to 6. Now, from here, let's solve for the value of b in terms of a. So let's do that. Let's divide both sides by 2. If we do that, we get ab equals to 3. Now, divide both sides by a, we get that the value of b in terms of a must be equal to 3 over a. Now, we will use these two equations to solve for the values of a and b. Now, again, take note that a and b are both real numbers. Okay, don't forget that. Now, let's replace this b with 3 over a. If we do that, we get something like a squared minus 3 over a quantity squared equals negative 8. Now, 3 over a raised to the power of 2, this will give us 9 over a squared. And now, let's multiply all of these terms by a squared to eliminate the denominator, a squared. If we do that, we get a raised to the fourth power minus 9 equals negative 8 a squared. Now, let's add 8a squared on both sides. This will give us a raised to the fourth power plus 8a squared minus 9 equals to 0. Now, the left-hand side of our equation, a raised to the fourth power plus 8a squared minus 9 can be factored as follows. We can factor this as a squared minus 1 multiplied by a squared plus 9. Now, since it is equal to 0, so we can say that at least one of them must be equal to 0. So we can say that a squared minus 1 equals to 0, or a squared plus 9 equals to 0. Now, let's focus on the first equation, a squared minus 1 equals to 0. Let's add 1 on both sides. And now, let's take the square root on both sides. Now, since the exponent is even, so we have two possible values here. So we have positive or negative 1. Now, we get that the value of a can be positive or negative 1. Now, how about on the second equation? Let's subtract 9 on both sides. And then do the same thing. Let's get the square root on both sides. And again, since we have an even exponent, we have two possible values here. But inside of the radical sign, we have a negative number, so we have an imaginary solution. So we have a must be equal to positive or negative 3i. Now take note, a and b are both real numbers. Therefore, this second case, a equals to positive or negative 3i, is not possible. Alright, so now let's focus on this case that a must be equal to positive or negative 1. Now we know that b equals 3 over a. So let's do that to solve for the value of b. Now we will replace this a with positive or negative 1. Now, 3 divided by positive or negative 1, this will give us positive or negative 3. It means that when a is positive 1, b is positive 3. And when a is negative 1, then b must be negative 3. Therefore, our answer to this question, if a plus bi quantity squared equals negative 8 plus 6i, then the possible values of a and b must be a equals positive or negative 1 and b equals positive or negative 3. And as always, we are done.